history of math class, and I was reading about Euclid, who wrote this book called Elements back in 1600, and what he wrote then are still the postulates and theorems that we use now. Like, he did all of this in book and wrote it, and like it's been taught for years of geometry and proofs. And I read that two-column proofs were introduced later to try to make life easier for you to prove things. You might think that it's worse, but they used to just all write out like long wordy proofs, and then they introduced two-column proofs for you. But like his stuff that he wrote in like 1606 are like the same postulates and stuff that we studied in chapter 1. So I thought it was really cool. Triangle sum theorem. We talked about this. You guys knew it already from previous classes, that the sum of the measures in the angles of any triangle will always add up to 180 degrees. And so they just wrote here that angle 1, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. A lot of problems today on your homework are going to just be solving for missing parts, maybe triangles joined together. But before we jump into that example, I want to talk to you about the proof of this. Like, why is this true? How do we know that the angles add up to 180?
Do we have a lot of proofs or
No. Maybe a couple. Maybe a couple. I know, well, I have it. You have to keep me there.
It's like yeah, you're back. You're back.
You're back.
You're back.
I got Laffy Taffy, and then if you get later, I might even have a chocolate. Maybe I have Laffy Taffy. Okay, there's no. All right, we have to talk through a proof before I give you that.
Oh my god!
Say so. Okay, so there's a proof of this in your book. I don't want you to look at it right now, but I'm not going to make us write it all out. I didn't even put a slide on there for you because I know you don't really care. I know you just want me to tell you the rules and then you just go with it and you believe everything. But the thing that I read in my book last night, and I feel like I'm a true mathematician because I'm doing what people in the 1600s did.
You've read that whole book?
I'm not all the way through it yet. This is week 5 of my class, and so I had to read through chapter 19 last night. It's called Math Through the Ages, A Gentle History for Teachers and Others.
The gentle history.
Gentle.
And then you open up, people start to yell at each other about math. No, this is math.
That's not math. That's math.
Chandler! Mathematician E.T. Bell once said, Euclid taught me that without assumptions there is no proof. Therefore, in any argument, examine the assumptions. Which means, like, you should question everything, right? That's what that's really pretty much saying. What to say? I was really, like, I felt like I was moved.
I felt like I was moved about math last night.
It says the de-emphasis of Euclid's logical structure in high school geometry is truly unfortunate because in today's world, the ability to view a situation in axiomatic terms and to deal with its logical structure is still very important, and not just in math. So when I'm teaching you about proofs, I'm not just teaching you about awful math, I'm teaching you to think through things and logically go to the next step and question everything.
Not very.
So anyway, I felt like okay. So this is kind of a long proof. I'm going to show it to you, but before I show it to you, I just want to talk about what we know. If we have this line of our triangle, and we draw in this line that goes through vertex A. Do you see that we have 2 parallel lines?
Yes.
Oh my gosh, didn't we just study stuff about parallel lines?
Yes.
What do we know about angle 4, 2, and 5 together?
Add up.
Because why?
Because they're
Linear pair, right? What do you know if this is a parallel line with this? What do you know about angle 1 and angle 4?
they're alternate.
And what do you know about alternate interior angles? They're equal. So angle 1 is equal to angle 4, so could I substitute angle 4 into angle 1 there?
Yes.
And the same thing with 5 and 3. Are those alternate interior? Which means I could substitute that in. So we could prove by using this linear pair here and substitution that that's why the angles in a triangle always add up to 180. All right, so it's not just made up. There's a reason why it's true.
It can have a line there.
Well, you have to construct it. Look, it's kind of a trick. We've never done a proof like this. It says, like, step 1, they give us a triangle. Step 2, draw that line in.
Okay.
Because if you draw in a line that goes through that, it'll always be parallel to it. And then I'm not going to bore you with all of this.
Is that why it's opposite?
Yes, because they drew it in. And so then they talk about that we have this linear pair. Linear pair means supplementary, and that we can say that those add up to 180. They're kind of very wordy
They give
here.
a lot of steps, like a lot.
I think I would have jumped right here to number 7 here.
Yeah.
4 plus 2 plus 5 adds up to 180 because it's a linear pair. And then they're going to do substitution. Angle 1 is congruent to angle 4. Angle 5 is congruent to angle 3 because of alternate interior angles. So then we can do, they got rid of the equal signs, or the congruent signs, and then they did substitution. But I just wanted us to talk through it before I showed you all of this, because it's kind of a long proof.
So we had to prove that angle 1 plus angle 2 plus angle 3 is 180.
Yeah, that's what we're trying to, like, this is the proof of the theorem. Remember that every theorem I give you, there's a proof to go with it. In this book that Euclid wrote in 1600, it was just a whole book filled with theorems and proofs. Like, it was like 161 theorems that he came up with and proved them all in this book in 1600, all by himself. And that was before all this notation, so it was pretty much all in words. But everything I tell you, every theorem I tell you, there's a proof to go with it. So sometimes the book shows us the proof, sometimes they ask us homework problems to prove them. But we're proving, how do we know they add up to 180 using parallel lines? Okay? So if you know this, you can do tons of problems now. So look at the next problem. Okay, softball. Woo! Complain about color and then I'll take it back away.
What do you call my brothers?
Okay, you have to not be distracting with this Laffy Taffy.
Oh my god.
I might run out by the way.
Can I take my note with? I thought so. What is
Oh no!
Pick it up, Chancellor.
Hey, what does Christmas have to do with a cat in the desert? Thank you. They both have Santa Claus. Thank you. Why did potato with giants? Because you wanted to be a French fry.
Wouldn't you rather have chocolate anyway?
What Christmas? Hey, which runs faster, hot or cold?
Okay, everyone, put their Laffy Taffy jumps away.
Okay.
Everybody,
This is the wrong
that was a good one. Find mine. Here's mine. Oh.
Alright, we're good now.
Okay, I'm just gonna go and then you guys can figure it out
I'm
later.
listening.
It says find the measure of each numbered angle. What would you do to find a missing angle in this problem? Which angle do you have to find first?
No. One.
How could you find angle 1?
Vertical angle. Well, it's vertical angles, and then it has to equal 180. So, snap. Go 43 plus 74 plus x.
Yeah. So I think you don't even need this triangle to find angle 1, right? Because you could say 43 plus 74 plus the measure of angle 1 equals 180. So you're going to do a lot of subtracting today. Again, my advice to you, especially on a test or a quiz, is show me what you're doing, because if you just do it in your head and you do something wrong, I can't see what you did, right? So if you miss it, then you miss a lot more points. Because I know you could just do 180 minus 74 minus 43, and you get the measure of angle 1 equals 63 degrees. So I can say 63. So Sydney, tell me another angle I can find now. If I know angle 1 is 63.
2.
How do you find the measure of angle 2? So what does measure angle 2 equal? 63. Because of vertical angles, right? And if you were trying to justify your steps, which it doesn't say, but that's because of vertical angles. So that means this is also 63. So, Grace, how do I find angle 3 now? you homework till, or Katie till after notes, just so you
Should've
know.
just waited.
I was right to begin with. How do I find angle 3? What's the triangle sum theorem that we just found out? What do we know? So how can I?
Set all those set 79 plus 63 equals 180.
Plus 3 equals 180, right? So I already wrote angle 3. So I'm going to say 180 minus 63 minus 79 to get that number there, right? I got 38. When you do your homework tonight, please try not to draw on your book, right? Or if you do draw on it, please erase it. All right, so look at the next one. Don't yell the answer out. I don't have it on the computers, but I thought you could just do this and we can hold our fingers in a minute. Find, they only want the measure of angle 3, but I'm guessing you're going to have to do some other work before then. If you don't have a calculator, I'll get you one if you want one. From these calculators. Did I catch
I'll just wait for someone else to say the answer.
But she froze it. Oh, who was that too? Well, it was like going like really high, and I was like, no.
Who else needs a calculator?
Oh well.
Honestly, I kind of just want to catch one.
It was like gonna either come down or it was
Oh,
gonna
come on.
up, or I didn't know if it was
Okay, you think.
and maybe you know if it was by throwing it.
What? Who else needs
But I've almost hit someone in the face.
Let me get one. One to throw it.
Stop. No, you don't get to throw them. Only I get to throw them. It's the bonus of being a teacher.
Maybe I'll become a teacher just so I can throw calculations.
Alright, kids, today we're gonna learn about throwing calculators.
So don't say the answer yet, but in a few minutes, in a minute or so, we'll do 1 for A, 2 for B, 3 for C, 4 for D. But don't do it yet, okay? No, I did all my calculator. I got a negative, but I knew that.
So negative.
Well, because I subtracted minus 180 and 180 minus 6.
Oh. So for Form 1, the big thing for that one is like, thingy-majig, or it's a distance formula.
Form 1 was really all about naming triangles, like knowing the vocab. Scalene, isosceles, equilateral, right, obtuse, acute, solving for it, knowing those things. So the vocabulary. That was Form 1. Yes, there was a question you had to do distance formula. That was kind of just extra one.
So if I didn't understand it.
Well, you should be able to do it. It's just doing distance formula, right? Like to determine whether a triangle is acute, scalene, isosceles, or equilateral, and its graph, you have to find the distance of each segment. We have a final exam coming up that definitely distance formula is going to be on, so it's not a bad idea to at least go back and check that you can do at least one of those
I already
segments.
had those.
All right, let's check here. A, B, C, D.
Brains.
I think C. C is the right answer.
It is. I was trying to put my pinky down. I was like, come on.
Right, and again, you can't. They ask for 3 because you have to do the other ones to get there. You have to find angle 1 first, vertical angles, and then subtract those, which I want to say that was 74. Was that true?
75. So yeah.
And then subtract that from 180 to get angle 3. All right, that's the kind of stuff you're going to see. All right, we also have this theorem called the exterior angle theorem. And it says, let me just uncover it here. The measure of an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. That's a whole lot of words there. So, using this picture, we can say the exterior angle, right, if you extend it, will always be equal to the sum of the other 2 angles, not the one right next to it. So, angle A plus angle B will always equal that exterior angle on C. Can anyone explain to me how we could show that that's true? Prove that? let's think it through again. All right, and I don't even know that I don't know if I wrote foolproof or not.
Click it.
No, because I don't want to click it if it's all there. What do you know about this angle and angle 1? They equal 180. What do you know about angle A plus angle B plus angle C here?
180.
So does it make sense if we take away this one angle that the exterior angle on the outside should add up to the other two? Do you see what I'm saying on that? Because they both equal 180? To me, that's the proof. Oh, look. Oh, I forgot. It's a new kind of proof. A flow proof.
That's right. Oh, it's one right before.
Oh, that explains why. Oh.
So, a flow,
It's too far away when he's talking about things that can bring.
No, it's not.
okay. Have you ever done like a concept map in biology class where you like have a circle and then you draw lines? You do that? A flow proof is kind of like that. So instead of, I'm a two-column proof girl, right? Like I want you to be able to do it any way you want. I want you to do paragraph proofs if it makes sense. I want you to do flow proofs if it makes more sense to you. To me, my brain works two-column. I like the organization of it. I like my statements with my reasons. A flow proof is where you can kind of have two things going at the same time and you don't arrows to get them together. All right, so
More confusing.
notice on this one, they say they give in, right? So you write your little box. You can make a little circle if you don't want to make a box. You can make a little cloud if you want to be cutesy.
Yes.
It could be like triangle, A, B, C.
What if you did a triangle and your A looks like just try to be cutesy, don't make fun of your A.
And then over on the other side, they're trying to put the two things that they're going to go together. So notice, if I was doing my proof, the very next statement I would have would say that I know angle 1 and angle 2 make a linear pair. Definition of a linear pair. I tend to always want to say like angle 2 plus angle 1 equals 180, definition of linear pair, but the book always does that 2 steps. So notice that they have their statement and their reason is underneath it. And then a flow proof uses arrows, which means it's really fun for me to grade because I have to follow the arrows. So following the proof, the next step would say if I know angle 1 and angle 2 form a linear pair, then I could say that they're supplementary. Again, probably the book's being a little extra wordy than they need to be because I want to just say they add up to 180. I'm guessing that's the next line.
Oh, I'm just gonna put that in.
Right? Like you could kind of put that together. Oh look, that's the next line. They say angle 1 plus angle 2 equals 180. So I would have made that more succinct there.
Can you just put definition supplementary for the
And then notice given the triangle. So when you do a flow proof, the arrows are supposed to be connected. So this really had nothing to do with the triangle, which is why it's in a separate column. What do we know if they give us a triangle? We know the triangle sum theorem that tells us that angle A plus angle B plus angle 2, right? Angle A plus angle B plus angle 2 adds up to 180. And if you ever say that in a proof, you have to say the reason is a triangle sum theorem.
you draw a triangle and then put some and then put some. How do you go with it? Wait a minute. Triangle angle.
So you kind of already see the lines are coming together, right? So whenever you have your flow proof, both arrows coming in, it means we're going to try to put these two together. What could I say? Do you know?
I don't get these things.
How did they say using, here's what's cool about it. It's in a 2-column proof. I always have to say, go up and look and see what you have and how you can put it together. In a flow proof, if they draw an arrow from here to here, it means they put those two together. And how did they do that? So how did they say that this is equal to this? What property? Yeah. I mean, I think either one would work. I would say substitution. They both equal 180. You could also say transitive. What am I trying to prove? I'm trying to prove this. What do I need to do to get from this to this? What's different from this box to what we're So how could I get rid of the measure of angle 2?
Subtract it on both
Could I just subtract it from both sides using the subtraction property? I know my tongue got really weird.
sides. Is that all now?
That's it. How do we know it's all? Because this is where we end.
I can write.
Some people write this at the end of their proofs. Q, E, D. I've never done that because my teachers never taught me that. But I read that in my book last night too. Euler did this. Isn't that what I said? No, Euclid. Sorry, I keep saying Euler. Euclid did this all the way back in 1600, and people still do it today. It means some Latin something.
It stands for proven.
It does stand for proven. It kind of does stand for proven.
Red.
So it's okay to put that, but it's not okay.
So we can say proven in Latin and be okay, but we can't say it in English or somewhere.
The Latin translation. Okay, so at the end, the proofs end with a restatement of the proposition, which was to be proved. The Latin translation of that is quod erat demonstratum,
Yes.
or abbreviation QED that often appears at the end of formal proofs. So I just am proud. I like to learn stuff. I'm a nerd. What can I say?
So if we don't know that very last step, we can just put
No, the only time you put QED after you're done with your proof. Does that make sense? So you don't put it as a reason. You don't say proven. QED means my proof is finished. Read it. That's what it means.
read it. That's what my proof is. Read it.
Okay, so again, I wanted to show you the proof of where the theorem comes from, and then you're going to practice using that theorem. So if I give you this picture, find the measure of angle FLW in the fifth flower garden shown, what do we know is the relationship between that picture?
It's triangle with line.
The hint is it says, use the exterior angle theorem. What did we just prove? What did we just say? What did we just learn back here?
You're right on my head.
Okay, so on that one, angle F plus angle L does 90 equal 180.
We learned what? This plus this equals 180?
Yeah.
Mm-hmm.
And then L plus O plus W equals 180.
Mm-hmm. So what is... So you're right. We could totally do this every time and go through all of this part again to get to what we want. But the idea is now we have the theorem, so you don't have to do all this work. You can just do the theorem that says the exterior angle will always equal the sum of the other two angles.
So is it 32 plus X or is it 32X?
You tell me. What does sum mean?
Plus X.
Plus. So we can say that x plus 32 equals 2x minus 48. That's why knowing theorems is so great. If you don't have to come up with what do I set it equal to, because you should know by the theorem. Well, you got to know these theorems.
Oh, that makes sense now.
Right? And then you're right, Audrey. You could totally do the whole thing again to get there, but you don't want to have to do all that work every time, right? So I'm going to subtract x this way. And I'm going to add 48 over here so I don't have negatives, but it's okay. Do I still have negatives? Oh, look, I wrote add and then I wrote subtract. 80 equals x. Did you get that? So what does it say? Find the measure of angle FLW. Where's angle FLW? The circled one? FLW. So, does this give me the answer to what it asks? No, I plug it in. So, angle FLW is going to equal 2 times 80 minus 48, or 160 minus 48. 112, is that true? I really want us to try to get better at putting degree symbols. It seems like they're finally in this chapter putting degree symbols. They haven't up until then, so I haven't been a real stickler on it. But if you're giving an answer for an angle, try to put a degree symbol on it. It's a good habit. In pre-calculus, I mark it off as stickler.
I bet you could Google it and find out like that. It was always named after somebody. That's where they get everything.
All right, do this one. Don't yell the answer out.
picture.
Oh,
I'm
no.
just kidding.
Miss Dixon, what have you done to us?
Most definitely.
I'm teaching you the question. I'm doing proper geometry teaching.
Yeah.
Like this whole, that book said, like, it's sad because sometimes in high school geometry now, you don't actually get into the proof stuff. Like, they've taken it away because people think it's too hard. But I felt justified last night that I'm making you do proofs because Euclid would want me to do that.
We're gonna put fingers.
What the heck?
Yeah.
It's like God.
Oh, yeah. So,
God.
not God.
No, it's not really God, but it's like
A, B, C, D.
oh my God.
So if you said B, that means you didn't plug it back in, right? D is the right answer. Okay, new vocabulary word. A corollary. You know what a corollary is?
What is
Corollary. It's a new word.
coral?
It's some sort of like name of a thing.
No, it's not a coronary.
That's coronary. A corollary is a theorem that makes sense because of another theorem. So sometimes you have a theorem and then they have a corollary to the theorem, which means because we have the theorem, the corollary makes sense. All right? So it's like in addition to the theorem, but it's its own separate thing. All right? So notice that these say triangle angle sum corollaries. We already have the triangle angle sum theorem, but these make sense because of that. So let's read them and let's see if they make sense to us or not. The acute angles of a right triangle are complementary. And look, I didn't make you fill the rest of it out there. So let's see, why does that make sense? What does the triangle sum theorem say again? What does it say? What's the first theorem that we learned today say?
The sum of the measures of the angles of a triangle is 180.
Angles in a triangle add up to 180. So why does it make sense that the acute angles in a right triangle are complementary? Audrey.
Because the right angle is 90 degrees and the rest of it has to be 90 degrees.
Because altogether it makes 180. So does it make sense that we can say this is 90, we know A plus B has to equal 90? Only if it was isosceles, right? Not all right triangles are isosceles. They don't have to be the same. One could be 30, one could be 60, right? They don't have to be the same. As long as they equal 90. All right? We could also use the exterior angle theorem to help us also. The one that we just did said, like, if that's 90, that's 90, and those two have to add up to that, right? That's another way you could prove that. So look, you're proving things right now, even though you think you aren't. And then this corollary for, actually Audrey proved that. 4.2 says there can be at most one right or obtuse angle in a triangle. Oh my gosh, we're so smart. We came up with that last week before we even knew this theorem.
What? We're so smart.
Someone explain to me why there can't be more than one right angle in a triangle.
Because then it would already equal 180, but there's, what about the other angle? He doesn't get anything.
Yeah, you can't have a negative angle in a triangle or a zero angle. You can't. So, and the same thing with obtuse. If one angle is already over 90, you can't have another one over 90. And those are called corollaries because if you know the triangle sum theorem says they can add up to 180, these make sense. Yeah, if it adds up to 180, that's how I can prove it. All right, so that's a new word, corollary. So now what can we do? Oh my gosh, look at this lovely picture. Find the measure of each numbered angle. Oh my gosh, there's five angles in one row.
We got this.
So don't yell them out. Look at what's marked as right angles. Oh my goodness, this is crazy.
Okay, so we know. Okay, I got the first one. I don't like.
Okay, so we know that eventually the answer's going to be given.
Chandler, you're really, really annoying me. I just want you to know that.
What's that hand noise?
Like, it doesn't even make me laugh.
That's when you know that
Like, it's okay to be funny sometimes, but it's not okay to, like, be like that all the time. The bad news is if we find one wrong, it could lead us to all wrong answers, right? Maybe.
Yeah.
I think I'd start with 5. Did anybody else start with 5?
I've already got 5, yeah.
Sure with one.
So I would start with 5 because, oh, I see what you could get with 1. Because if this is 41 and this is 90,
Yeah.
you can subtract from 180, or if you know it's a right angle, we could use that corollary and you could just take 90 minus 41, right? Which would give you 40. So I'm saying angle 5 is 49 degrees. What do you think?
I agree.
Okay.
But then you can get angle 2 also.
How'd you get angle 2?
You do 48 plus 56 and then subtract from 180 and then do that.
So that gives you 76. So that makes this 76. All right, who said that they did angle 1 first? How did you find angle 1?
This 56 and angle 1 are, well, yeah, technically you could do it that way. I did. It's okay.
How do you know this?
Could we do the exterior angle?
You could do, that's what I did.
Like, angle 1 would have to equal the sum of what two angles? You see what I'm saying? Or no, could we just subtract 180 minus 76? Would that work too?
Yes.
I was doing the exterior angle theorem where I was adding these two together, but that should be the same as if I take 180 minus that. Alright, so let's see. I'm getting 104 for angle.
I know how to find 4 too. Yeah. So what you do for that one is, well, you know that's a right angle. Yeah, right there, and then the bisector, which makes the two, which makes it in half. So you know that has to be 45, right? It seriously just.
You're saying you think this is 45?
Well, yeah.
But what does it say right here that this is?
That's where you do. Oh, so it's 90.
Right? Okay, so you have to take 90 minus 34 to get that, because it tells us that that one's 34. We cannot say it bisects it unless it tells us.
I wish it did.
But it tells us it's 34, which gives us that this is 56. So then can we subtract to get 4? 76 minus 56, 48.
Yeah.
3 was the easiest to find.
How'd you find 3?
Because that over there is a right angle.
This is this one?
Yeah. So then the other side of that has to be right angle. So then you just, yeah. 90 plus 48, and then subtract that from 180.
That's true. We have a theorem that says if this is a right angle, like that's a right angle, we could use linear pair to show that. They tell us this is 48, so we can just take 90 minus 48. Yes? 42? Is that true? Look at how much math we just did. Look how many theorems we just did in one problem. So here's why the theorems are so important. If we didn't have those theorems, we couldn't find the answers to all this. So that's why you have to know what the theorems say. Are you going to have to do a ton of proofs? No. But you need to be aware of the theorems as you do a couple proofs, and you have to know the theorems to do problems like this. All right, look at the next one for you.
Cheese crackers.
So hot for it. All right. Crushed all my hopes and dreams. I only want angle 3 on this one, but I'll give you a few minutes. Ready, go. Oh, I know 5. Okay. Oh, yeah. Okay.
Oh my gosh.
Yeah. All right.
How did you?
Don't show them. Oh, okay. I gotta do some work. I want to write on this. Yes, Garrett, I agree. I concur. Garrett got that right away. He was super fast. I didn't even have the answer yet to check with him. Anybody want to show answers yet?
No.
It's not working.
No.
What did I do?
we're looking for 3. It'd be really nice if you could find these 2, right? That's what I think you should do. So how could you find this one, Ellie?
Can I say how you would find that one over there?
Yeah.
Okay, you take 180 minus 135.
Right, because it's a linear pair. So what do you get there? 45? Right, because it makes it with that. So you really don't even need this part. What about angle 2? How do you find angle 2?
Well, angle 1, we find angle 1, and then see what the vertical angles are.
So what did anybody tell me what they got for angle 1?
50.
So that means this is 50.
So,
So 50 plus 45, subtract that from 180.
yeah. Anyone got that answer?
Yeah.
I think it should be C.
Okay, so,
Because you get 95 plus 85. Right, so that would be one. This is one why we don't trust pictures, right? 85-degree angle kind of looks like a right angle. Like that looks close to a right angle, but we don't assume it's a right angle unless it's marked. So I think we're getting there. I think we've made a breakthrough in our questioning thing. So, but if it wasn't multiple choice, right? Most of your test is not multiple choice.
Because
This is
you
check
saw
for
angle
understanding.
3 and you thought it was close to 90, so you put 85.
So you are doing 12 through 44 even. I know I'm evil. Because I didn't want to use that as a paper. So make sure you write this down. This is homework 4-2. A lot of it is just finding missing ones. I will tell you 30, what page is this? 248 to 250. 44 says write a flow proof. Try it, right? Try it out, and then you don't have to do any more flow proof after this. I'm sure we'll talk about it tomorrow, but I just want to see an attempt on 44. I think that's the only one that's approved. The rest of them are just finding missing parts, which is why I gave you so many. Which I still think is less than 20 problems, so.
Wow.
But you're probably
This